So good morning or maybe good afternoon, everyone. Thank you for joining us today. And my name is Sergey Gulko. I work with XTRD Order and Execution Management for digital assets trading. And the main topic for discussion today is how to use FIX API to build something which can help you to operate reliably on today's crypto markets and potentially on other markets as well. And another topic we would like to discuss today is what kind of benefits you might have working with a FIX API versus REST WebSocket or whatever it is. So first and foremost, we as a company, we are a member of FIX trading community. We've been doing what we're doing for the last seven years, I believe. I'm one of the co-chairs on blockchain and digital assets group and FIX trading community, and we do our best to promote FIX API over the REST and WebSockets because we truly believe that it has certain benefits and advantages. Prior to XTRD, I was running my own software development company for about 15 years, and we've been working with the FIX API during probably this entire period. So we, as a team, accumulated huge pile of hands-on experience dealing with the different protocols, pitfalls, problems, and we, or at least I would like to see, I would like to think this way, that we accumulated this experience in our current product. And during today's session, I will do my best to share at least part of what we learned. I see some familiar, not faces, but at least names here. And for those who know me, and for anybody else who don't know me, I usually brag a lot that we have clients who finished integration with our system within 5 months. Oh, sorry, 5 hours. They literally completed full integration in 5 hours. I said, okay, let's see how it's doable. So I set a timer for 12 hours and run some sort of coding marathon to see what can I do as a developer to build something over the FIX API. So today I will share my step-by-step approach on what I achieved and what kind of problems I faced integrating with the FIX API. So first, at the beginning, why we believe that the FIX is superior over the REST and WebSockets, especially for crypto trading. Well, it's not only about crypto trading, but nevertheless, as a majority of you, I'm sure know that crypto exchanges are usually run on REST and WebSockets. We use FIX API on client-facing side, and the main reason for this is primarily for performance and standardization. Because when you work with FIX API, you more or less know what to expect, what will happen next, how the market data will be provided, how the orders flow will look like. Because when you deal with REST and WebSockets API, it's all different, and it simply take you time to get used to API, just a single exchange, because they're literally different in terms of fields, workflows, requirements, and so on and so forth. with a fix API, the message structure defined, the workflow is defined. Yes, they still might every change might have own flavor of fix API, but at least once you build single connector with one exchange with one venue, you can repeat it again and again and again. And the second part is performance. Fix usually overperform web stack only because it has just one layer less, because WebSockets run on top of HTTP, which run on top of TCP IP. Fix run just simply on top of TCP IP. It's a minus one layer. It sounds silly, but when it comes to performance, every microseconds counts. Okay, so I will share my screen. Screen. For the sake of presentation, I was for this presentation I was using Java because I'm more or less comfortable with Java or C++, and it's our languages of choice. But you can repeat the same steps on pretty much any other language. .NET, Python, JavaScript, it's completely up to you. Fix API itself, it's totally language agnostic, and you can build connectors from pretty much every language. So we have clients who works with us absolutely without any problems from JavaScript, Rust, Python, and obviously Java and C++. When it comes to Fix API, so what is a Fix API itself? How it works? So Fix API on a lowest level represents it's bidirectional connection which you can use to send messages and receive messages. It's totally asynchronous, so you should not expect to receive a response on your message in the meantime. So it's an extremely bad practice to send message and set a wait timer. I saw it multiple times many years ago, but it's a bad idea. So when you build on Fix, you should prepare yourself to completely asynchronous operations. So you send a message, you fire and forgot, and that's it. And sooner or later, hopefully sooner, you will receive confirmation. So your entire system design should be able to work with event-driven messaging coming through the Fix pipes. So the Fix pipe itself, it's simply TCP/IP socket, and the Fix protocol itself just a set of messages formatted in a special way. I will not go deeply in how it's formatted. My goal is just to explain how it works on a higher level. There are multiple Fix engines or libraries which can be used to maintain Fix connectivities and format messages, parse messages, and provide some high-level infrastructure on top of protocol itself. I know several companies who don't like use Fix engines and prefer to build something in-house or work directly with the TCP IP sockets. It's good for them. Maybe we are not that extreme and prefer to use ready-to-use Fix engines. In this example, and we will be using Onyx Fix engine. We are very intimately familiar with this product, but it can be easily replaced with quick fix or fix antenna opens pretty much every engine. It's just question of choice. So let's get started. I structured, as I said, I set a timer and created this created set of small applications to depict every step of building simple but nevertheless functional fixed application. So in the first step, what we want to do is establish connectivity. Establishing connectivity in terms of FIX API, it's literally providing certain credentials, which is host, port, username, password. Username and password, it's optional fields, and it sort of depends on it's vendor specifics. It's vendor specific, and if your vendor doesn't require you to use username and password, you don't have to. In our case, you have to use username and their password. I created a small configuration file. I created a small application which actually do a really simple thing. It's start the application, read information from the configuration file, and when I click start, it's simply create a login message with username, password, and required username. Yep. This is our sample number 1. This is a small tool, open configuration file, read market data session settings, host, port, target comp ID, sender comp ID, username, password. We indicated that we don't have to use SSL, short bit, and simply show this on the screen. So it's pretty straightforward. The goal of this small utility was just to show basics of fixed session management. For example, we can start session. Can we start it? Okay, our lovely problem. Let me restart VPN. There we go. Okay, so the life cycle of fixed session is relatively primitive. So there are about 4 different states. It's connected, established, waiting for confirming logon, and it's when it's specifics of Onyx Fix engine. In Quick Fix, it's a little bit different, but the logic it's very similar. When you start a session, the first message you have to send it's literally a logon message. Logon message might include username and password, might not. In our case, we use username and password, as I said before. So we start. We can start. We can stop session. The application itself do really nothing except starting and stopping itself. When it comes to building trading application, or at least from our standpoint, you have to accomplish several things. You need to have market data. You need to understand how your balances and positions looks like. You have to have ability to shoot orders and receive confirmations in real time. And when it comes to crypto, you need to understand, is your counterparty dead or alive? It sounds funny, but unfortunately, multiple crypto exchanges doesn't work really reliably, and we even built a specific layer of checks just to make sure that we capture all disconnects and downtimes and notify clients explicitly. So I will back to this topic a little bit later. So market data. Market data is probably the most complex part in every application because it's require a lot of computation power, bandwidth, and some approaches to manage the data itself. When it's come to data, to market data over the FIX, the most important part and most common problem we saw over the course of last 6 years in XTRD and last 15 years in my software development career, it's a buffer problems. So when you consume market data, you should act as fast as you can, because we send, well, not only us, but many participants send data relatively fast, and once your TCP/IP buffer become overflowing, then the counterparty simply drop connection. We call it slow consumer, and we saw it multiple times on the initial stage of integration when our clients came and said, okay, let's connect to several exchanges and consume entire all 1,400 symbols from Binance, 300 symbols from Coinbase, from OKX, and so on and so forth. But when they build an application, so they decided, okay, so we will parse and process all the symbols in the same thread where we run application, where the FIX engine runs, and this is usually core of the problem. Why it's core? Because your system, well, I'm not saying that your system is bad, I'm saying it's just sometimes it's happening because computational logic on your side might be fairly complex. For example, you might run a Monte Carlo simulation on every tick, and this technically simply block your FIX engine from consuming data, and market data updates starting to pile up. So what we recommend and what we do on a daily basis when we run integration for someone else, simply use dedicated threads to process data. So you receive data in one thread, you parse it, then you shift parsed messages to the dedicated processor, which manage books, manage business logics, shoot orders, whatever it is. It's not always necessary, but usually works in 90% of cases. Another good point is simply increase FIX engine buffers if possible. Some engines allow you to do this. Some is not. But in our case, as I said, we use Onyx. We can manage buffers relatively easily. Another optimization option, which might be interesting, it's just tune your operation systems configuration, because when you have like a freshly configured system, it's usually runs on just basic parameters just to run, and that's it. There are multiple tuning options for Linux, and I'm sure for Windows they also exist. For example, you can increase TCP/IP buffers. If you need this information, just ping me on LinkedIn. I will share with you our own practices. We have a document how to tune network cards and tune kernel for Linux to achieve better performance. Okay, so back to market data topics. In terms of market data, we have several messages in our system to manage data. First and foremost, you need to know what kind of instruments are available. So for example, we have just connected, and let's see OKX. So on OKX, we have multiple symbols. To fetch this information, we use message called security list request. It's pretty straightforward message. Only one thing it's changed. It's a security exchange. In our case, you simply supply the exchange name, send the message, and we will not we, but many systems simply respond you back with a list of messages called security list. There are multiple ways to stream security list back to the client. Some implementations use single security list message with lots of repeating entries inside no related SYN group. In our case, we prefer to send messages one by one, because there are some changes might have relatively big number of instruments, like 8,000, and sending pretty much everything under a single message might be not that efficient. Security list message in our case has indicators that how many messages should be sent, and either message you receive is actually the last message for your own request. For example, we just fetched list of messages, a list of available symbols from OKX. You can do the same, for example, for Coinbase. Coin, I'm not sure. Okay, KuCoin, we don't have any symbols for KuCoin on our demo environment. Okay, so OKX. Let's see what we have here. Wow, 27,000. I love it. So what I just did, I sent a subscribe message. Our system allowed to subscribe and unsubscribe on multiple symbols coming from multiple exchanges simultaneously. So in order to start consuming market data, you need to send market data request. At this moment, we support several types of market data entries. It's bids, offer, and trades. And in the near future, we'll provide funding events as well. You can subscribe on symbols from different exchanges, on multiple symbols simultaneously. For example, like this, Coinbase. What we have on Coinbase. Coinbase. Yeah, well, $10 premium between OKX and Coinbase. Nice. Even better. So you can consume data. You can, as well as you can subscribe, you also can unsubscribe through the FIX request. It's the same messages they're using to subscribe and unsubscribe. Only should simply send it, and you're good to go. So just to illustrate how the message looks like, it looks exactly as I described it in her specification. I actually use a specification to build entire request. The market data, we want to subscribe, we want to receive incremental updates, and we want to receive bid, offer, and trades. So difference between incremental updates and snapshots, it's simple as that. So snapshot, it's your entire order book in crypto, it might be ridiculously huge. In, for example, Binance case, it's 2,000 bits, 2,000 offers. It might be even better. Wait, sorry, so it might be even bigger, several thousands. We prefer to keep it in a more or less reliable shape. And to keep market data flow efficient, we use incremental update approaches. So when you subscribe, you receive a market book snapshot, and once you get it, we start feeding you with incremental updates, which are explicit comments what you have to do with your existing book snapshots. You have to add new level, new price level, remove level, or for example, update price on a certain price level, update size on a certain price level. So we did this process as simple as possible. So you don't need to synchronize something like you might do on Chicago Mercantile Exchange or Binance. So we always send information in a predetermined order. So it's snapshot, and it's always followed by a list of incremental updates. And every update you receive have to be applied to existing order book to maintain its integrity. The step number 3, it's not really a fix API thing. It's more on management side. So for those who familiar with our system, we have application what we call client portal, where you can manage your accounts, connectivity with exchanges, and it's actually an essential part of building trading systems. So like I will simply show you step number 3 quickly. It's a REST API for management of your assets. You can create accounts, you can create so when it starts, it's reads here is information from the system through the REST APIs. For example, we want to add March 21. Okay. Create a trading account. Let's see, it's actually created. Yep, there, and let's add exchange connectivities. So for today presentation, I will be using OKX. So all those operations can be done through the user interface, but as I said, my goal was simulate building a trading system API to API. So I built a small wrapper. All those credentials are demo. It's not linked to real money, unfortunately. Private key, password. So the goal of this API is create a seamless integration between our system and your system. For example, if you're a trading platform, you don't have to force your clients to register with us, open accounts, and go to client's portal. You can do it through API. So the clients don't even have to know who is doing what. Okay, so okay, so it looks like my VPN is dead again. We can do it manually from here. And OKX password. Yeah, we use OpenVPN to provide access to our facility, and unfortunately, it not always works perfectly. OKX. Okay, so we'll add OKX, let's set Deribit, and then we'll move to trading itself. API key, private key, username, save. Else Coinbase. If you use Coinbase for simulation, it's actually bad idea because, for example, in our demo environment, we stream real prices, but Coinbase demo accounts are linked to their own pricing engine, and I tested today. For example, Bitcoin was trading on 27 plus something, and Coinbase demo accounts was executing on 22. It might create additional issues. Okay, we just added several exchanges. Start Deribit, start Coinbase. Nice, Coinbase. Okay, no, not a big deal. Okay, so the step number 4, as I said, the most important part is understand what, not most, but again, relatively important part is part to understand what is happening with your exchange connectivities. For example, we have OKX, Deribit, Coinbase here. And okay, this management part. Yep. Now we're working. Perfect. So for exchange monitoring, we have a message called trading session status. When you start your application, you simply subscribe on receiving updates for trading session. And trading session, it's a combination of your account. It might be your account, might be your client account, and their exchange. So for example, here we have account March 21 with their 2 exchanges associated. So it's OKX, Deribit, and Coinbase, who is actually failed to start. It's even better, actually. So at the beginning, once trading session is connected, so I added another session in configuration file. Once trading session is connected, we will shoot message called trading session status request. It's again, it's super simple, just 2 fields. Let's see. What's Java? So just 2 fields, and we will receive snapshot of existing connectors associated with all linked accounts, and the server itself will push a notification in real time if status of particular trading session will be changed. So right now, let's connect to the trading session. Let's fetch information about sessions. So you see we have OKX, we have Coinbase, and we have Deribit. Let's check how it actually works. So let's stop Deribit. So it might be stopped manually, might be stopped by change. Sometimes they go down. Okay, so your system will receive notifications through the FIX API using trading session status message, which contains information what kind of connectors is down. You'll receive explicit connector name. This might be OKX, Deribit, and you will receive information about associated accounts. You might have more than one account, might be tens, hundreds, thousands. It's completely up to you. So you will always know what connector is went down. Okay, let's start our those folks are up and running. Let's see what we also can do. So as I said, next pillar of building trading system is to have information how your balances are and positions looks like. To achieve this, in FIX protocol, there is a message called request for position. So you literally subscribe on updates on balances changes or positions changes, and the server will notify you if, for example, you bought some BTC or receive some Ether. We, in our case, this request for positions, it's not as my favorite message, because it's relatively complex to construct, because there are several moving components. For example, our system is built in a way to serve other businesses. So you might be a trading platform and you might have multiple sub accounts on your behalf. So you need to create, you have to have ability to create a complex structure from different accounts, different positions, and their separate execution and balances from each other. Again, it's completely up to you, but we build it in a way to be a multi-tenant. So multiple accounts under with different permissions and different resources. So, and in order to receive updates for balances, you have to send fairly complex constructed message which indicate for which account you want to receive updates, for which exchange you might not, and it's this complexity is usually achieved through the repeating groups. Repeating groups is one of the FIX API ways to provide not structured information inside the message. It's usually meta information, and we use it extensively in multiple messages to stream information about accounts, exchanges, and positions. So we have several code samples for request for positions. Just to illustrate it in action, we connect and build request. So this request is just fetched information about all my balances and positions associated with my single account and two exchanges, and it's also aggregated by assets. For example, I have altogether 3.6 unfortunately virtual BTC. Let me check. Really, so yep. So I have 0.94 on KX and 2.6 on Deribit in BTC. And also I can have a split view filtered by account, for example, and by exchange. And there, if you sell or buy something, server will also send you a notification in real time saying, okay, so right now your BTC balance is that. Right now your BTC perpetual, you own 100 BTC perpetual contracts. So everything is real time. You don't have to pull it in a constant basis. Our system will send you messages through the FIX API. And the only one thing you need to do is parse it. And as I said, the position reports are relatively complex in terms of structuring. It's have multiple repeating groups, and in our practice, it's potentially the most questionable message because it's not not really intuitive. We as I said, we have multiple samples. And I will share this code base with pretty much everyone. We have people to help you to navigate how it works, but I have to admit it's complex, and I don't like this message. But nevertheless, it's how it looks like. There are multiple fields. You want to receive snapshot and updates. You want to receive information for the particular client account, which is March 21. You can receive you can receive updates for the particular exchange or for entire organization. There are multiple ways you can construct your subscription. And this flexibility obviously comes with the complexity. And once something changes, server will push you back message called position report. The position report contains all required information you see here. So you will see you have asset, you will have information about exchange, you will have information about size, and all this information are coming in real time. I will show you in the next step. So right now we have market data, we have positions, we have information about our trading session, and let's jump to my favorite topic, to actually trading. For trading, we have several messages. There are message to open order, message to cancel order, message to change or amend order. You can do it. You can conduct all these operations through the API. Well, obviously through the API only. In a FIX API, workflow is created in the following methods. You send the request to open order, and server will respond back with multiple messages or confirmations called execution reports. Execution reports it's indication of it's message to carry indication of your current order status and how your request to do something with order was processed. So it might be rejected, might be canceled, might be accepted. And in our case, we always keep the same workflow for every connected exchange, no matter what. So when you send an order, there are just two cases how we can respond. We can reject it immediately, or we will send you a pending new execution report saying, okay, so we accepted your order and we start working on it. Next potential message, it's execution report in status new, and then field, partial field, or cancel it in between. So there is no vice versa like many crypto exchanges do. They sometimes can send you cancel followed by multiple fields. Sometimes I even saw field, cancel, field, and then new. And we hide all those implementation details. We send messages in an extremely predetermined way. So it's always rejected or pending new, followed by new, partial field cancel. Okay, so let's shoot some orders to illustrate how this new order single works. So new order single is a message to create a single order, and any order it has just basic parameters like start sessions. Let's see what we have in BTC. So we'll use 27,000. Okay. So each order has multiple characteristics. It's a symbol, site, you want to buy, you want to sell. its order size, its types. We support just 2 types in this moment. It's just limit and market and multiple time and forces. It's like good to cancel. It's how order will live and how it will behave once it hit exchange. We also support execution instructions like on exchange, crypto exchanges call them post only, something like this, or why I decided to skip it on this user interface, but you can submit it through the FIX API. This, as I said, exchange call and post only, but in reality, it's participate, do not initiate, do not increase, do not cross. Let's okay. Let's place some order on OKX. Okay, so what was price? 27. Okay. Let's say we want to buy 0.1 BTC at the limit, just to make sure that we execute it. 28. Okay. Yep. On the top, I show the orders itself, their statuses, and below it's actual execution reports. And here, as I said, it's an entire workflow and set of execution reports. Once you send an order, our system sends you back pending, new, and field. And every execution report contains multiple fields, which help you to understand what is actually happening with your order. We send you IDs, timestamps. For field orders, we send commissions, last prices, last sizes, average prices. It's lots of information to deal with. And unlike to market data session, which usually have to be placed in a separate thread, actually not a session, but processing facility have to be placed in separate thread. Trading sessions are less aggressive in terms of messaging flow. So potentially you might manage your orders in the same session, in the same thread as you parse fixed messages. Even if you conduct market making activities, it's still less than our entire exchange market data flow. So you might stick in the same thread and do not create additional load for your system. Because based on our experience, the less threads you have in your system, the better it behaves. It's obviously not a solution for pretty much everything, but in most of the cases, it's better to limit the number of threads you run simultaneously, because every threads are coming with additional resource penalty, because your CPU and operation system have to spend additional time to switching between contexts, and it might look nothing, but when you have hundreds and hundreds of threads running simultaneously, it's create problems. But based on our previous experience, it's better to keep number of running threads reasonable low. Okay, so we send an order, we receive confirmation. Let's place, for example, pending order, which will stick in the book, for a while. Limit. We want to buy for 27. Just to, you see workflow for this order is pending and new. It's not executed because I want to buy for 27, and right now Bitcoin is trading on 27 and 800. So the order is sitting in a book. Okay, so we can update it from here, or we can, for example, cancel it. Yep. and everything is coming through execution reports. And what I especially like about Fix API is the processing and business logic when you work with execution reports, normalized execution reports are extremely straightforward. This is how our parsing for execution reports looks like for our own system. I want to share with you how parsing of execution reports and orders management looks for Binance or Bybit, for example, but it's a nightmare. It's lots of ifs, else, switches, internal logics. It's crazy. Only because when exchange use web technologies, it technically use multiple, not really correlated with each other channels, and you have to adjust your system to be capable to deal with messages coming in a random order. With a fix and with a potential system like ours, everything is streamlined and coming in a predetermined order, one by one. So your processing logic, well, looks extremely straightforward. That's it. So this is only one thing you need to do: statuses, prices, sizes. That's it. Good to go. Oh, it looks like we are running late. So to be honest with you, this was step number 6 was the last I finished within 12 hours marathon. Step number 7, it's basically just a reordered application I built, but it took me additional several hours just to change forms layouts, but in general, it works. It looks like this. Okay, let's start all lovely sessions. Connected. Positions, balances, market data. I want to see, subscribe. We don't have the bit. Okay. Otherwise. Right now, it looks like a real trading application, and literally 12 hours of effort, and you're good to go. Well, I think this is all for presentation. I will share with you source code if anyone needs anything like documentation, links. I will be more than happy to provide you with. And if you want, if you need some, I can answer questions right now if you're not in rush. Because I don't have any other planning activities, so I can simply sit here for additional extra hour.